We now focus on how to study DC circuits containing MOSFETs. Our study will involve both design and analysis. The more you practice, the quicker you will be able to accurately deal with such circuits. In this lesson and the upcoming ones, we will neglect channel length modulation and take lambda to be 0. So, let's get straight into this. Design this circuit so that the transistor operates at ID equals 0.4 mA and VD equals 0.5 volts. The NMOS transistor has these specifications. You are to neglect the channel length modulation, that is, assume that lambda equals 0. So what do we mean by design? By design we mean finding the values of RD and RS. First of all, notice that VGD, which is equal to minus 0.5 volts, is lesser than VT. Therefore, we can see that the MOSFET is operating in the saturation region. So what is missing? We are missing the value of VGS. Let's use the current equation to calculate that. This gives the value of VGS as 1.2 volts. Now notice that the gate is at ground potential. Thus, from the value of VGS we just calculated, we can conclude that the source must be at minus 1.2 volts. And using that, we can find the required value of RS. This comes out to be 3.25 kilo ohms. Now, to establish a DC voltage of 0.5 volts at the drain, we must select RD using this formula. The value comes out to be 5 kilo ohms. And congratulations, this is what we were asked to do. Are you ready for another example? Let's do this. In this second example, you have a current of 80 microampere. You have to find the value required for R and find the DC voltage VD. The specs of the NMOS are also on your screen. So, let's do this too. Since VGD equal to 0 is less than VT, we conclude that this MOSFET is also in saturation. So, again we notice that VGS is missing and we calculate it via the equation of ID. This gives us a value of VGS as 1 volts. So the drain voltage will be equal to 1 volts again. But why? Look. VGS equals 1 volt, but we notice that the source is grounded. So in reality, VG equals 1 volt. And as we can see from this part here, that VG and VD are shorted, so VD is also equal to 1 volts. Now, to find the missing value of R, this is pretty straightforward and it comes out to be 25 kilo ohms. Practice this yourself and you'll get a hang of it.